Hi everybody. Today we're going to be looking at how to create a line of best fit for a set of data. Specifically, we're going to be looking at that data in the form of a scatter plot. So here is a scatter plot. Scatter plot is a graph of plotted points from a set of data. What we're going to try to do today is look at scatter plots and come up with what we call a line of best fit, which is also known as a fitted line, which will show a relationship between the two sets of data from these data points. Let's jot down this definition of line of best fit in your notes right now. As you're jotting this definition down in your notes, I will share with you that usually a line of best fit or a fitted line is used to help make predictions about data. One last thing I'd like to share with you is that throughout this video and in this math class and in future math classes, you will sometimes hear the term line of best fit, and other times you will hear the term fitted line. These two titles are really the exact same thing, so some people might say line of best fit, some people might call it fitted line. They are the exact same thing. Okay, as we're taking notes, let's just get these notes down right away. The steps for drawing a fitted line are pretty simple. Number 1, circle the data points. Number 2, use a ruler, and that's important, use a ruler, to draw a straight line so that about half of the data points are above the line you draw and half are below. A point to note is that your fitted line that you draw with your ruler should be within the circle that you drew in step number 1. So let's try that with this given scatter plot. Remember, step number 1 is to circle the data points. All right, I'm just going to sketch a circle around those points. There we go. Okay, step number 2 is to use a ruler to draw a straight line so that about half of the data points are above the line and about half are below the line. So perhaps something like this. Notice that when I drew my line, it goes all the way across my graph, and if I take a look at my points, I've got approximately half above that blue line and about half of them below the blue line. Okay? It's important that I don't just make a tiny little dot-to-dot drawing. It goes all the way across my graph. Okay, if you have not done the 2 steps, circling the data points and use your ruler to draw your straight line of best fit, please pause the video at this time and do that right now. All right, ladies and gentlemen, take a quick look at this. This is a common mistake that some students make when they skip step number 1. Okay, this person did not circle the data points, and they just did step number 2. They drew a straight line so that half the points were above and half were below. However, notice that the person's line of best fit does not follow the pattern of the dots. So what this person has really done is created a line of best fit that does not follow the pattern of the points in the data. Big mistake. Big. Okay, ladies and gentlemen, we're going to take a look at a new scatter plot. This scatter plot is about the mean annual temperature in Celsius in Nevada based on the elevation in meters. Remember, our first step is going to be to draw a circle around the data points. So there we go, and hopefully you did that along with me on your scatter plot. Our next step will be to use a ruler to draw a straight line, so about half of our data points are above the line and half are below the line. So we're going to go ahead and do that. Remember, we want to make our line so that it will be across our whole graph. Okay, now that we've made our fitted line, in order to make a prediction, our problem says predict the temperature in Nevada in Celsius if you are at an elevation of 2,400 meters. So to make this prediction, we're going to go to where 2,400 meters is along the x-axis, and I'm going to predict it is right around here. Okay, from there I'm going to draw a line going straight up. Now you guys are going to do that with your ruler. You're going to go straight up to your fitted line. From the fitted line, then we will go directly left to find out what the temperature will be. Okay, so I'm going to go directly left, and I'm going to make an estimate with my fitted line, a prediction that if I am at 2,400 meters, that the mean temperature will be 4 degrees Celsius. Okay, and just so you know, we will be looking to see, do you have that line going straight up and straight across on your graph? Okay, ladies and gentlemen, the last thing that we're going to ask you to do with your fitted line is to be able to identify its slope and y-intercept. So just to brush off the cobwebs, refresh our memory a little bit, slope, which our variable for is m, is equal to the change in y values. So remember this, y2 minus y1 over x2 minus x1. Okay, so in order for us to find the slope, we need to pick 2 points that are on our fitted line. Now, we want to pick points that are going to be easy to work with. I also strongly recommend that we pick points that are not too close to each other. We are going to get a more accurate slope if we choose points that are a little bit farther away from each other on our fitted line. Okay, so since I'm going to try to pick decent points, I'm going to start right here with 500, and I'm going to go up to my fitted line from 500 and put a point on the line. Okay, looks to be about there. Okay, so hopefully you can see my green dot right there. And I'm also going to find a point on my fitted line that's around the 200 meter elevation. So from 2,000. Right from 2,000, I'm going to go straight up to my line of best fit about here and put a point. So these are the 2 points that I'm going to use to calculate my slope. All right, so that first point, the green point that I put on my line of best fit, looks like its value is 500, and its y value is approximately 19. Okay, that second point on my line, the purple point, is at 2,000, and I'm going to say that's around 6. So now I'm going to calculate my slope from there. So remember, m is equal to the change in y's. So I'm going to go 6 minus 19, y2 minus y1, over x2, 2,000, minus x1, 500. Okay, 6 minus 19 is negative 13, and 2,000 minus 500 is 1,500. Okay, so that's my slope. A lot of times when we're doing a line of best fit, we put our slope into a decimal form. And if I do that, negative 13 divided by 1,500 gives me approximately negative 0.009. Okay, now most of the time we are used to writing slope in a fraction, but oftentimes when we're calculating line of best fit, our slope is written as a decimal. Okay, the last thing we're going to do is look for our y-intercept point. Okay, remember our variable for the y-intercept is b, and remember it's called the y-intercept because it's where does our line cross the y-axis. So all we need to do is look at the y-axis, and we're going to estimate our y-intercept point at approximately 24. So I could, in fact, write the equation of our line of best fit. So I would say that our equation could be written as y is equal to negative 0.009x plus 24. All right, ladies and gents, that's it. You go fit some lines.